Good morning, viewers. Today, today's subject is physics, and the topic is resolution of vector. To get the understanding of this WAEC past question taken from the year 1989, question 3, objective. So the question reads as follows. A boy pulls a nail from the wall with a string tied to the nail. The string is inclined at an angle of 60 degrees to the wall. If the tension in the string is 4 Newton, what is the effective force used in pulling the nail? Now, first and foremost, I want us to follow a particular format to help us in solving this question. One, we're going to have our given data. Then we have a diagram where necessary. Then we have a formula. Then we have a substitution, evaluation, and units. So we want to follow this format in solving our question. Now what we consider here is that we have to get the background knowledge of this particular question. So considering our right angle triangle, this represents the resultant. This is a vertical force, horizontal force, and your angle is given here. So your understanding about SOHCAHTOA will help us here. The X represents the sine, the O represents the opposite, the H represents the hypotenuse, the C represents cosine, A represents the adjacent, H represents the hypotenuse as mentioned earlier, T represents the tangent, O represents opposite, which is the one we mentioned earlier, and A is the adjacent. Now, how do we know the opposite? The opposite is the side facing the given angle, while the adjacent is the side not facing the given angle, and the R, which is the resultant, is the side which is the hypotenuse facing the right angle triangle symbol. So we have sine theta, which is opposite all over hypotenuse. Then we have cos theta, which is adjacent all over hypotenuse, and tan theta, which is opposite all over adjacent. So our vertical component, so this is going to give us sine theta is equals to Fy, which is the opposite, all over R. That is our hypotenuse. So we make Fy, solve the formula. Fy will now be by cross multiplying. We have R sine theta, and that is our vertical component. Then our horizontal component is cos theta is equals to Fx all over R. So we make Fx, sorry, formula. That will be Fx is equals to R cos theta. That is the horizontal component. So now, by what I have just given us here, I told us that we have to bring our data out, but let's draw the diagram first. We have the wall. This is the wall. We said a ball pulled a nail from the wall with a string tied to the nail. So we have our nail here. Then we have the string tied to it. The string is tied, but the string is inclined at an angle of 60 degrees. So Here is the string. This one represents the string at an angle of 60 degree to the middle. So this represents our right angle triangle. So if the tension in the string is 4 Newton, here T, which is the R, is equals to 4 Newton. Now, what is the effective force used in pulling the nail? If we are to pull the nail, to be effective, you have to pull it horizontally, because when you pull it vertically, it's going to bend the nail either upward or downward. The nail will be bent, but it is ideal and reasonable that you pull it horizontally. That represents the effective force. Therefore, the one that is more reasonable is going to be the horizontal component. So we're going to use the formula of horizontal component, which we have derived. That is our fx is equals to cos, that is r cos theta. Now, that is the formula to use. But now let's bring out our given data. Look at it. Our r, it's equals to what? T, which is equals to 4 Newton. Then our theta is equals to 60 degrees. Then our fx is unknown. So this is given data. The next, we have drawn our diagram. Then formula. The formula to use is our fx is equals to r cos theta. Then the next is substitution, evaluation, and units. And that will give us our fx is equals to our r 4 times cos 60 degree. Fx is equals to 4 times cos 60 is 0.5. So fx is equals to 4 times 0.5. 4 times 5 is going to give you 20. Then, you have one decimal point, take it back. That is going to give you 2 Newton. Therefore, the effective force that will pull the nail out of the wall is the horizontal component, which give us the answer to the question, and we have our answer to be option A. Thank you for watching. Please help me to help share and also subscribe and like. Make a comment where necessary. God bless you all.